The overall goal of the following experiment is to synthesize a functionalized bis-peptide using solid phase techniques. This is achieved by loading a protected bis amino acid onto hydroxymethylbenzoic acid resin. Then deprotection coupling cycles are repeated to attach functionalized bis amino acids, a process that elongates the bis-peptide and displays desired functionality. Finally, the first bis amino acid is modified with an alpha amino acid in order to cleave the bis-peptide from the resin by diketopiperazine formation. Results are obtained that show the successful synthesis of a functionalized bis-peptide in good crude purity and consistent isolated yields of approximately 10% based on liquid chromatography mass spectrometry analysis.
The implications of this technique extend towards parallel and library synthesis of bis-peptides. Because the bis-peptides are assembled on a solid resin, which is more easily manipulated than reactions in solution, and byproducts are easily removed by filtration.
Visual demonstration of this method is critical, as many of the steps are difficult to learn because there are many important details necessary to ensure that all of the reactions approach completion as closely as possible. With solid phase synthesis, there is no way to purify intermediates, so in order to obtain a clean final product, every reaction must be driven as far as it can. We recommend creating a checklist of experimental procedures to avoid confusion, since the steps are repetitive in nature.
This protocol begins with loading of the first bis-peptide.